Hi and welcome back. My name is Idan, and in this section we are planning to learn the main service models that are available for cloud computing. What is a service model? What kind of service should I use for a specific use case? What's the difference between software as a service, platform as a service, and infrastructure as a service? In order to choose the right service model, or maybe a combination of service models, we must fully understand what each service model is actually offering. So let's start to answer those important questions. I would like to remind you that you can also use the course dashboard as a great interactive tool to ask me additional questions. You probably heard that more and more businesses today are relying on cloud services to do business. Now this trend is getting more and more momentum in the IT industry. But how those services are actually divided? So using the National Institute of Standard and Technology definition for cloud computing, we already reviewed the 5 essential characteristics of cloud computing, including the on-demand self-service, broad network access, rapid elasticity, measured service, and resource pooling. Now, the next important definition of cloud computing is related to the main service models, and according to this definition there are actually 3 service models. Let's see them on a diagram. The different kind of services that cloud computing platform provide can be grouped together into the following service model: software as a service, platform as a service, and last one is infrastructure as a service. They are called as a service because on one side we have a consumer that is using and paying for specific service being provided by a cloud service provider. We can also overlay them on a pyramid structure, and together they are making something that is called the cloud computing stack. The cloud computing stack is very useful to understand the service models. Starting with a high-level definition, we can see that there are 3 distinct service models that are built on top of one another. Each cloud service model provides some level of abstraction that reduces the effort required by the service consumer to perform specific activities. Infrastructure as a service, as the underlying layer, provide computing, networking, and storage virtual resources using the cloud infrastructure. In the middle, we have platform as a service that is used to provide a framework to develop and build application on top of a cloud environment in more easy way than infrastructure as a service. And on top, software as a service is used to provide application to end users. When we go higher on the stack, the consumer has fewer concern with developing, managing, and maintaining the solution. If we go lower down the stack, the consumer has more responsibility and of course control over the solution. If we will take one step back to understand the context to traditional IT approach, and this is what we see here on the left side, all the building blocks in a standard IT environment. In traditional on-premise data center, organizations are hosting applications on their own private physical network and IT infrastructure. Now, to be able to do that, in each organization there is an IT team that has to build and manage everything. They have to install and manage the local network, storage devices, multiple servers, adding virtualization layer, operation system, middleware and runtime servers, databases, and multiple applications. This is traditional IT. The customer is responsible for everything. Now it is time to see how cloud services are changing this model. Starting with infrastructure as a service, as this is the foundation of the cloud computing stack. the first layer that we saw. Infrastructure as a service provide compute power and storage services on demand. Instead of buying and installing the required physical resources in traditional data center, organization can rent these required resources as needed. There is of course a cloud infrastructure where we as end users can access and allocate virtual resources to host application. Everything is provisioned and managed over the internet. For example, this is the resource pooling capability that is so useful in cloud computing. Here we have three end users, the blue, green and orange, that allocating virtual resources as needed. Now those end users will be responsible to configure and manage each virtual resources that they allocated, but they are not managing or controlling the underlying cloud infrastructure. They can quickly scale up and down with demand and pay only for what they actually used. Now looking on the same computing stack that we saw before, but now the cloud provider is responsible for the whole green part. Okay, you see that's divided to provider and customer. The capability provided to the consumer is to provision computing, storage, networks, and other fundamental computing resources. We can see that the infrastructure includes three main building blocks: networking, storage, and servers. And under each building blocks, we'll find many different services that we don't see right now. For example, under networking, we will find the ability to build virtual network connection, allocate IP addresses using load balancer for traffic, firewalls, domain name services, etc. Under storage, we will be able to find different storage options, enabling to store the application data, and inside the server layer is where we can allocate virtual machines. And on top of that, the cloud provider is using some kind of virtualization layer. So let's say that I created 5 virtual machines using such service. Now I'm responsible to install the needed operation system, middleware and runtime servers, databases, and any relevant application. This is the responsibility breakdown between the cloud provider and the customer using that specific service. Who is doing what? Now, from a business perspective, I remove the whole complexity and expenses that are usually involved with planning and managing and maintaining such infrastructure. Now the cloud provider takes on those responsibilities. Instead of purchasing, installing, and integrating new hardware, customers can simply allocate cloud resources in order to build their own IT environment. You will agree with me that this is a major mind shift in the IT industry, where companies will reduce the investment in private data center and shift the IT budget to a cloud provider. But this is not just about the money, it is also related to the trust level that is needed, so organization will trust an external cloud service provider when they are putting their valuable digital assets in the cloud. Moving to the next service model, platform as a service. Platform as a service is a framework allowing customer to develop, run, and manage application without the complexity of building and maintaining the IT infrastructure. PaaS is sometimes confused with infrastructure as a service, but it is another abstraction layer sitting on top. Let's take a simple example. I need a database server for my application. Okay, I'm developing a new application on the web. One option is to use, of course, the infrastructure as a service, allocate the needed virtual machines, install the operation system, and of course the database application that I need to use. Okay, this is option number one. Another option is to use platform as a service. Now I'm selecting a platform that is pre-configured with specific database management system. And I'm ordering that like a single service catalog items. In the background, this platform that I'm going to use can be based on multiple virtual machines, pre-configured as a one application platform. Even more important is that in such a platform as a service, the cloud service provider now manages the entire platform, including the operation system, needed upgrade, patches, and all the support are actually handled by the cloud service provider. This is what makes platform as a service unique compared to infrastructures as a service. Now, the main use case for platform as a service today is actually related to the development of an application. It is a fully managed platform, an environment for developers to build web application much quicker. So it's very popular between developers as they would like to put their concentration on developing a new application and put aside all the management and maintenance of such underlying infrastructure and leave it to the service provider. And this is what we see on the right side. All kind of different developers that are using the platform as a service solution for developing new application. Now, some example of platform as a service from well-known cloud providers will be the Microsoft Azure App Service, Google Cloud Platform, the Google App Engines, and in Amazon AWS, the Elastic Beanstalk. Looking on the cloud computing stack, here we have on the left side the platform as a service, and you can see that we have more green layers if you compare it to infrastructure as a service. So the responsibility breakdown between the cloud provider and the end customer is better than infrastructure as a service. The provider will now manage additional layers like the operation system, middleware, runtime environment, need the database, web server, etc. And the customer are only responsible for their specific application and of course the data. In simple words, with such platform as a service, we can develop and host our application in the cloud without the headache of building and maintaining the underlying infrastructure. Software as a service, or in short SaaS, is the most mature and popular cloud service model today. It is a software solution that is hosted in the cloud and accessed through the internet. It is an on-demand application delivery model operated by a third-party provider. We can think of a SaaS as a software on demand, as we basically rent a software for a specific subscription period instead of purchasing it as a license. As you know, with license-based software model, we need to purchase the software, install and maintain it, and perform version upgrade from time to time to keep it updated. With SaaS, we just simply subscribe to the application using some package, and then end user can access it online from anywhere. SaaS vendors typically offer two ways to use their application. The most common method is, of course, a web-based user interface. And this is what you see here, company A and company B, that are using a simple browser to access the service from anywhere in the internet. The other way is to use a specific set of API that can be used to access the service, and this is what you see here, company C. Gmail is a simple example of software as a service. You log in into your email account from multiple locations using simple internet connection and consume the service. You don't care where the actual servers are located, who and how they are managed and monitored. You just care that your account will be available and secured. Now, some very known example in the market can be Salesforce. They were actually the first company offering SaaS-based CRM solution for enterprise customer. The famous Office 365 from Microsoft with the Office package delivered as a service. The popular Dropbox for storing data in the cloud. And there are, of course, endless more examples of software as a service application aiming to different purpose, customers, and end users. Looking for the last time on the cloud computing stack, we have the SaaS on the right side. Here, it is completely the opposite to traditional IT, meaning everything is managed by the SaaS provider. Now, SaaS providers have total control over the infrastructure, performance, security, privacy, and much more. Now, one important disadvantage is that SaaS solutions are usually aiming to the mass market with generic functionality that can be used by multiple customers. And this will reduce to some level the customization flexibility compared to a tailored software solution installed in a traditional IT environment. Still, SaaS is well accepted service model and it's getting more and more momentum in the market.